Okay. So all of you pay attention. Here is our base model, which is VGG 19. Now, what does it mean? Why have I named it base model? Because we are not going to use this model as it is. We are going to customize it as per our own problem. Okay. This model was meant for classification of a dataset which had 1000 different objects and images of shape 224 by 224 by 3. But we have loaded this model without its top, that means a fully connected part. We have only loaded its convolution part, and we have customized it to receive the input shape of 32 by 32 by 3, which is how our images are. Now, in order to complete this, we need to add our own fully connected layer. So that will be our final model. And that is why I have called it base model, which looks like this. It is very easy to understand. Now let us create our final model, or let's simply call it a model where we add the fully connected part to this one. So how we are going to do that? First, we will start with an empty model. Then we will add this base model there. And after that, we will simply add our new layers. So I hope all of you are aware that there are different ways to create the architecture. One is that inside a list you provide all the layers. One is first you create an empty model and then by using the add function you keep on adding different layers to this one. So that is the method we are going to use. This is the empty model. First, we are going to add base model. Now, what does it mean? You may ask, sir, this is not a layer. So how exactly are we able to add this? So when we say model dot add base model, basically all of this will be added to our model. So now this model is basically all of this. After that, let's say if I want to add the fully connected part. So let me ask a question to all of you. Which layer I have to add first? This is the output shape of the convolution part based on the input. So now I need to add the fully connected layers. But before that, what I need to do? What I need to add?
The dense layer.
No. Dense
Flat,
layer is for that fully connected part. What we need to add before
Right.
dense layer?
flatten layer.
Correct. Why?
Because the output format here is in 1 cross 1. It's in a 3D format, so we need to convert this into a 1D array, which can be used as an input to the dense network.
Correct. So we need to convert it into a format in which the dense layer receives its input. Okay. Never say 1D array. It can be 2D also. You can simply say a vector,
Okay, my bad.
right?
Yes. Yes.
Vector. We need to convert it into a vector. Okay. So first we add the flatten layer. Then we add our fully connected layers. Now, given the data set, what should be the choice of activation function in the final layer? First, how many neurons should be there in the final layer?
10.
10. So I hope all of you remember we had 10 different classes. And according to this, what should be the choice of activation function for output layer?
Softmax.
Softmax. Are all of you aware how softmax works?
No.
Yes?
Yes.
No, I'm not aware.
Okay, today let us continue with the project because it will take some time. Maybe when it is training, then I will explain. We can utilize that training time to take your doubts. So here is our final model. First, it shows that VGG19 base model. Then we have our flattened layer, dense layer, and then finally our output layer. So this is what our architecture looks like. So what we have done, we have loaded an already available architecture and we have customized it as per our own problem. Very simple. That's what we have done. Let me share it with all of you. Now we are ready to train it. Now that process I hope all of you have created many projects. So you see that process is very simple. It is almost always the same. You just have to change the loss function according to the problem. So let's do that. First step is compile. Here you will mention the two objects that we created, train generator and validation generator. Is there any parameter in this that all of you are not aware of? I'm assuming all of you have created a lot of projects, so this part is almost the same. So you understand everything. But still, I'm asking, is there any parameter that anyone is not aware of? Like why we have mentioned something here?
Can you explain optimizer, Adam? Possible?
Have all of you used the Adam optimizer?
Yeah, we have.
So are you telling me to explain the mathematics of it or what?
Yeah, like how it works. Why do we
No,
use
no,
optimizer?
that will consume our whole session. So you see, we
Okay.
have the stochastic gradient descent.
Yes.
So I hope all of you are aware with gradient descent. Then, or over gradient descent, the first optimizer that improves the process we have is gradient descent with momentum. Okay. If you check that SGD function, if you explore it in the website in a documentation, so there is a parameter called momentum. So what that momentum does is it uses something called exponential weighted average. So that concept means that instead of using the gradient at each stage, we use the exponential weighted average of previous few gradients so that we can maximize the process towards the minima. Okay, like we can minimize the fluctuations away from the direction of minima and we can maximize the movement towards the direction of the minima. So I hope all of you are aware the gradient descent kind of looks like this. Okay, it's like a 3D diagram. Let me draw its top section. So this is where we need to reach. So when you are trying to minimize your function, this is your minima. It is a top section view, right? Like when you are looking from above. So the journey can be like this. Done. This is with basic stochastic gradient descent. Now the momentum one says that okay, instead of using the gradient, we are going to use the weighted average of previous few gradients. Now how that helps us is it is easy to see when you are using the you are adding or you are using the exponential weighted average of previous gradients, then you are making sure that the fluctuations or the components that result into fluctuations in the opposite direction, they cancel out each other, obviously simple maths. And then the components which cause movement towards the direction of minima, they add each other because you're not having any movement in the opposite direction, so those will get added together always. And then those who are in the directions away from the minima, they will be cancelled out. So it kind of accelerates the process a little bit. Instead of having many fluctuations, it will be like this. Correct? That is SGD with momentum. Now, above that, you have RMS prop. What does it do is it makes the learning process adaptive. So you ignore very large or very small jumps. Okay, it makes a learning process adaptive, that you are taking similar steps at each stage. So that also minimizes the fluctuations. Then Adam finally is a combination of both of these optimizers. Adam optimizer is a combination of momentum also, RMS prop also. So it is accelerated plus adaptive. So this is supposed to work the best or the fastest 8 out of 10 times. So that is what I can explain for now. If I explain all the maths, then it will consume the session. I think I have a
Mm.
PPT. Maybe I will share
Yeah,
it with all of you. Let me check.
yeah. Thanks.
Okay. So you see, there is this whole subject which normally not required in courses like these, but let's say if we are teaching at some postgraduate courses, then these things are mandatory. Okay. You can spend a whole semester only on understanding how you can fine tune the training of your neural networks. All these concepts are covered there. Effect of learning rate. Okay, what are different things that affect the training, and then you have this concept of gradient descent. You can see here gradient descent with momentum, right? In order to understand that, you first need to understand what is the concept of exponential weighted average. Then comes your RMS prop, and then your Adam is finally the combination of RMS prop plus the momentum. Okay, so I will share this with you. For now, I don't think I have enough time to explain this. I hope that is fine. Let's
Yeah, it
continue now.
was fine.
So I hope all of you understand all these parameters. Now we simply need to execute this train
Excuse me.
generator.
I've got just one doubt.
Yes.
Uh, in this model, you're using four fully connected layers, right?
Yes.
Yes. So how do we actually know how many fully connected layers do we have to use in in a model? Like, or do we just
That
do it randomly?
no, that you have to experiment a little bit. Whether it is machine learning, whether it is deep learning, especially deep learning, we are never sure that, okay, how many are going to be sufficient. So you have to do a few experiments. And let's say when you create two or three or four projects like that, then you start having a basic idea, okay, where at least I need to start from. Correct? Then you will know, okay, here I need at least two. Here I need at least three. Like this one, before showing it to all of you, first I checked with three layers. Okay, 500, 500, 10. Okay, it didn't work very well. I mean, the results were close. It's not like if you use three instead of four, you will get very different results. No. Let's say here, if you are getting 89, there you will get maybe 84, 85. So in most of the cases, it is fine. So you have to experiment a few times to see the best results. You may have studied it. We call it hyperparameter tuning. So in case of neural networks, the number of layers, number of neurons, these are your hyperparameters. You have to try a few times to get an idea where to start from, and then you will see which one can give you best results. So I checked with a few things like 4 to 5 times. That is why you see this time limit has exhausted for me. I
Okay,
had to
okay.
use a different ID. So I figured out, okay, this one is working best. So it is something you have to figure out. There is never an answer, okay, for a situation, three sufficient, four sufficient, five sufficient. Got
So,
it?
also, like, is there a like like in machine learning we use grid search or randomized search, right? So, is there something like that in neural network, or we just do it?
Yes, there are libraries also. There is one library called weights and biases,
Okay,
and there is one more. I'm not getting the name, which helps you do this. But in neural networks, the manual thing is better.
okay, okay.
I mean, it is easier. In machine learning, doing it using grid search and everything, it becomes easier. But in neural networks, manually, once you are starting out, I mean, in big neural networks, big projects, obviously you would like to automate it. But here, while you are in the learning phase, I suggest it that you try, because if you are not trying for first 5 6 projects, then you will never have even the basic idea. Getting my point?
Yes, yes, got it.
That's why.
Thanks.
So for now, you just try. I mean, let's say when I share this notebook, then I suggest you try. Here I have used VGG 19, maybe you try VGG 16. Then try with 2 layers, maybe 3 layers, and then see how things work. That's how you will start having a basic idea.
Okay.
Okay, let me check what is this error.
I'm not able to connect to the runtime. I don't know why.
I will help you. First, let me check if it is running correctly. Then, while it is training, I will take doubts from all of you and also help those who are not able to complete it or facing any errors. Okay, so seems to be working. Let me check the next epoch also. Okay, it is fine. Now, those who are not able to complete it or facing any errors or any doubts can ask me. While this is being trained, we will take doubts for 10 minutes and then we will start with OpenCV, and this will keep on training in the background.
Can you share that base model VGG 19 thing? I think we did not share that.
Okay, let me share this one with the final code. So all of you just need to click on, but then it will not serve the purpose of hands-on. You will not have to write anything. Let me share the base one. Received? After that, all of you have to do this, this, and this. Yes, can you copy paste your error if in the chat? What is the error you are receiving?
Okay.
Sir, for the GPU issue, we should change the ID, right? Different mail ID.
Yes, that is a trick. So let's say if you have exhausted the limit, daily limit, so you can change the ID, obviously.
Okay.
Yeah, if you are facing the same issue, usage limit issue. So you try with a different ID. Has Google reduced its limits? I mean, I tried multiple models, so I was getting that error. But how come all of you are getting this error? Did those who are getting the error, did they try more after the session? Or it was only during those 3 hours? Tell me.
Only during the 2 hours. So are you suggesting I use a different email?
Yes. Are others also getting this usage limit issue? Okay.
Yeah, trying with other ID.
Seems like Google has reduced their limit. Kaggle is also an option. So I'll wait 10 minutes while this is being trained. All of you can ask me doubts related to this project. After that, we will start with OpenCV. Yes, Shantanu.
Yeah, initially we had when we downloaded the data, there was a set of test data as well.
Right.
We are not using that in our model.
No, that we will use. That we will use for testing. Like here, we are using the training and validation data. Once the training is complete, we will make predictions on the test set, and then we will compare our predictions with respect to the actual labels of the test set to get the idea of the performance.
Instead of validation, we can use test as well, right?
No, not instead of, along with.
So we have to use both
Yeah,
validation
we are
while
using
training.
both. Like here, while training, we are using training and validation set.
Yeah.
Okay. And once the training is complete, then we will do testing once again using our test set.
Now my question is, if we can use testing data as well, right? While training instead of validation, instead of creating
Yes.
another set of validation.
Yes.
Yeah. And then predict with some unknown image, which we have not, I mean, some different image.
Yes, can be done. But you need to have labels also, right? That's why three different sets.
Yeah.
Can you scroll up to the compile line? I think there's some characters. Can you once again please explain this validation? Why do we use validation val generator? Or like for training also, why do we use validation?
This val generator is the image data generator object we have created for our validation data. Like it will take a batch
Yeah,
of
yeah, yeah.
code value.
That was clear. It's
Right.
just the concept. Like, why do we use validation for training as well?
Validation, you do not have to think of validation as being something different than testing. You see, testing and validation are both the same thing. It's just we are giving them different names. So while we train neural networks, you need to compare it with how machine learning projects work. So in machine learning projects, nothing like this happens. Like you're training, and at for each epoch, you're also checking the performance on a different set. Correct? But in case of neural networks, while we are training, we also have this facility, you can say, we also have this option that we can check how our model is doing on the training set. This one is training loss, training accuracy. This one is validation loss, validation accuracy. So we have this option to check the performance on the test set also. That means first for this epoch, it will be trained on this set, and then it will be validated or tested on the validation set. So we can see both the performance. Now, we also have the option that we do two-way testing. Okay, one we can name validation and one we can call testing. Validation meaning, okay, while training we have one set, And then once the training has completed, then we have another set to check the performance. So this is just an option. Do not get confused like validation is something different and testing is something different. No, both of them are just methods, exact same methods to evaluate the performance of your model. In case of neural networks, as we have this functionality, we can check it for each epoch. So it makes sense that here we use a different set and here and while testing we use a different set. That is the concept. Making sense?
Okay. Yeah, yeah, yeah. Thanks.
It's not like validation is something different, testing is something different. No. Testing is similar to machine learning. Like you train the model, okay, then you make predictions, compare the predictions with actual labels, right? In neural network, it happens for each epoch. So we are doing it this way also, and we are doing it later on with the testing set, how we used to do with machine learning also. So we are doing two-way evaluation, validation plus testing. Or you can also say testing plus testing, but doesn't make any sense. So let's just call it validation.
Okay. Yeah, yeah, got it. Hi, one doubt, like for accuracy, right? Do we always have to, like, as you said, we need to experiment with the layers and the parameters. So do we always have to wait till it completely trains and gives us the accuracy, then we again go and change the parameters and then do it again? That's the only way, right, to figure out.
Trying different model also works. Instead of VGG19, try something
Yeah.
else. Try different
Mm.
layers. Try the uh, try to control overfitting. Okay.
Yeah.
Try to use batch normalization. All these techniques are there.
Okay, okay, okay. So, but that's the like only way to go, right? We don't have any other way.
Yes.
Okay.
Okay, so this will keep training in the background. Yesterday also I asked, are all of you aware with OpenCV library? Tell me in the chat with a yes or no. Have you been introduced to OpenCV like an OpenCV tutorial?
I haven't been introduced, but just like have heard and saw it, have seen it. I mean, but it was not introduced in the classes.
Okay. So it's an important library to perform computer vision tasks. First, what I will do, I will give all of you an introduction of this library, the most important or basic functions, correct? An overview only, not in depth. And then we will also create a project for face detection from images. Fine.
Are we
So
going to do that with the Har Cascade or?
yes, that one only.
Okay, okay, okay.
So has it been done in the classes?
No, 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 it hasn't.
Okay. So for this one, all of you will need a few images. I have shared them in the chat. You can download these or you can download images from the internet also. We will need them to check a few things. Images received.
Yes.
Yes.
Which last code? Okay. So let us start our OpenCV tutorial. Now, what exactly is OpenCV? So OpenCV is a library which has a lot of functions for performing computer vision related tasks, right? There's a library for natural language processing NLTK. Similarly, there is a library OpenCV for computing. But I guess all of you have not yet studied NLP, right? So I shouldn't compare with that.
Yeah, we have not said.
Okay. So OpenCV is a library which has a lot of functions that you can use to perform tasks related to computer vision. And that is what we are going to see today. We are going to use some of the most frequently used functions that this library offers. It's a huge library. There are a lot of things. So this is no way a complete tutorial, just important and most frequently used ones. Okay. So first of all, we have to install this library. Okay, it doesn't come pre-installed with Anaconda. So we have to install it, which is very easy. So for me, it says requirement already satisfied. For all of you, it will start installing if it is already not there. So quickly update me with a yes in the chat if you have successfully installed this library. Done?
Yes.
Other candidates? If all of you are not doing these things hands-on, then you can let me know so that I do not ask these questions frequently. That whether you have done it or not, whether you have installed it or not. I am assuming that everybody is doing hands-on. That's why I'm asking these things. If you tell me, okay, no, we are just here to understand and we will do it later, then I will maintain the flow accordingly. Let us import the required libraries now. So OpenCV Python is a package, and this package gives us this library CV2. Okay, this is what we will be using.
We are doing this installation through Anaconda console, right?
You can do through Anaconda console also, but Jupyter also allows you to do this installation. If you use this exclamation mark, this allows you to write any command that you would normally be writing in your Anaconda console. For
No,
example,
I mean to say, I mean, we need not have to go to Google Colab, right? Because it would be running from Anaconda console only, right? I mean, the node, Jupyter notebook, right?
not understanding. Google Colab for what?
I mean, we need to execute this, install this by using the Anaconda console by going ahead with the Jupyter notebook option, right?
No, Anaconda console is different.
Okay.
I'm confused a little bit. Ask the question again. What exactly is the
What
case?
I'm saying is, in order to use the Jupyter notebook, right, we used to have Anaconda installed on our system. And in
Yes.
order to access Jupyter, we locally, instead of going ahead with Google Colab, we used to go, open the Anaconda, then we used to open the Jupyter notebook, and then we used to install this package. So is this the right way actually we need to do?
Yes.
Okay, right.
You have to install it first in order to use it.
Sure, thanks.
You can install it from here also, or you can open the Anaconda console. There also you can write the same command like this. So both the ways are available.
Okay, fine, thanks.
Okay. So now that we have imported our libraries, we can start. So very simple operation. First of all, we need to know how we can read an image using OpenCV. So this CV2 library offers a function called IMRead. Okay, so this function takes the path to an image and then it will read that image into whatever variable you are storing it. Now, if your image is in the same folder, then you can just write the name. If it is in some different location, then you can give the path to that location. If it is in some path, in some folder or subfolder or the current one, you need to give that path. If it is on any other directory, then you need to give the location relative to the C directory. I hope all of you have done that. Now, let's see what exactly is the image that we have read. For that, we can use the IMShow function from matplotlib. Why? There is a show IMShow function for CV2 library also, but that doesn't show you the output in the same Jupyter window. Okay, it will open like a different panel or a different window. You'll be able to see it in your taskbar, and there you will see the output. Fine. So that sometimes creates problems. Okay, you have to close it, and sometimes it shuts off the terminal. It doesn't work very well with Jupyter. So most often we use this plt.imshow to visualize our image so that we can just see it below our cell. It doesn't matter. So we have read the image. Now let us print the image and see how it looks like. So here is the image that we have read. You can check in the folder also. This is the image. Simple function to read the image. In case anyone wants to know in what format does it read, so it actually reads in the NumPy and the array format only. So here we are using the function. Now if you check what exactly is this panda. Okay, let's check the type of this panda variable. So it is an ND array. Okay, if you check its shape, 931 by 1400 by 3. So that is the shape of this image. Now, Now it will not be useful what I'm going to explain, but when you create projects related to OpenCV, you use ND arrays and images. There you will be having a lot of confusion when you do the calculations. So pay attention here. Here it says 931 by 1400. Now what does it mean? There's a difference. Let's say this is our image. Okay. So when we talk about resolution of an image, how do we represent it? Horizontal number of pixels by vertical number of pixels. Yes or no?
Yes.
Yes.
Right? That's how resolution is represented. So resolution of this image is actually 1400 by 931. Correct? But your ND array shows it like this. Why so? Because ND array works on the concept of axis. So I hope all of you know this about ND arrays. This is the zero axis and this is the one axis. Yes or no?
No, I don't have
So
idea.
that is the way it shows you the information. So always keep this in mind. Whenever you are printing the shape of an image as an that exists as an ND array, you will see the vertical number of pixels first and then the horizontal ones later. Because this is the zero axis, this is the one axis. The actual resolution of that image will be this by this. What you see next is the horizontal number of pixels. What you see here is the vertical pixels. If it is grayscale, you will see one here. If it is RGB, you will see three here, but that doesn't matter. The only confusing part is this, right? Later, when you do object detection, you draw bounding boxes. A lot of calculations are there. There, this creates a lot of confusion. So the resolution of this image is not 931 by 1400. No, the resolution is 1400 by 931. Clear to everybody?
Yes.
Yes.
Okay. Always remember this. Okay. So we have seen how to read an image. But if you see these side by side, then you will realize that there's a bit of difference in these two. I mean, when I'm sharing the screen or maybe when you're printing it on your screen, can you spot the difference? Okay, this one is black and white, so maybe you will not spot the difference. Let's use a different image. Okay, so I have printed one of the images. Now let's have a look at the actual image. Can all of you spot the difference between these two images? Is this exactly same as this one?
The background
Yes.
is like, yeah.
There is a difference. There is a difference of color format. You can
So one
see.
is like bit of grayscale kind of thing, and the one color is
No, not
very like
exactly grayscale. This one is normal image, RGB. This one is BGR. So always remember this. Okay, very important. Let me write it as a comment. By default, whenever you read an image or do anything, so by default, every image in CV2 is in BGR format. Okay, BGR simply meaning blue, green, and red, just reverse of RGB. So by default, everything in CV2 uh, is in BGR format. Okay, this way you will remember. So now we need to learn how do we change the color format of an image using OpenCV. For that, we have a function called CVT color. In this function, first we need to provide the image for which we want to change the color format. Okay, I'm providing this image that I have read here. Then we need to mention what exactly is the operation we need to perform. So that is mentioned as an attribute. cv2.color, and what we are doing is we are doing bgr to rgb. If you are doing rgb to bgr, all you have to do is provide here the rgb image and then write cv2.color rgb to bgr. That's it. So now this function will convert our bgr image to rgb image. Let us print. Here, now compare the images. Now they are same. Yes or no?
Yes.
So this is the important point all of you need to remember, that by default all the images in CV2 are in BGR. Like if you are to read one of these images, let's say of someone's face, then also it will be like a bluish color because everything is reversed. Whatever components you had for R, now they are for blue. Whatever components you had for blue, they are for red, R. So it gets reversed. Red becomes blue, blue becomes red. So the complete color changes. Like if you are to read this image, maybe you can try it on your end. You will see Thanos purple kind of image rather than this one. Okay, let's continue. So next important operation that is required very frequently is grayscale images. Okay, a lot of tasks you perform, object detection, face detection, and many more, they require input in the form of grayscale because they care about the patterns only, the geometry, the patterns, not necessarily the colors. So we need to see how we can convert an image to grayscale. Yes, if we
Please, can I see your line of code for your panda?
I'm copy pasting it in chat.
So why did you use plt.asix of?
So normally when we print images using the matplotlib function, it shows this grid because it is a matplotlib plot ultimately. But in case of images, it doesn't make any sense. It's not like I'm creating some scatter plot or line plot, so I need to see these. So to get rid of this grid, we
Okay.
also call this axis, not grid. I'm sorry, axis. We call this axis. We just say axis off.
Okay, thank
So
you.
when I use this, you will not see this. You will only see your image. Grid is different. Grid is that those lines you see in between if you have created a plot. This is axis. Okay. Now we are going to learn how do we convert an image to grayscale.
What is minus 0.5 and
It is just the way it represents this image. So normally the resolution of this image is 1140 by 630. So it represents it like that. 1139.5 minus 5, 629.5 minus 0.5. It is, these are the internal parameters of how this PLT dot function is creating this image.
yeah, thank you.
So whenever you see this, so just assume the actual resolution is 1140 plus 1140 by 630. I think I printed it somewhere. Here it is like 1399.5, 930.5. So this is the actual resolution. 931, 1400 or 1400 by 931. Okay. So here there is nothing different. We just use the same exact CVT color function in order to change the color format. That's it. If your original image is in BGR, you mention BGR to gray. If your original image is in RGB, so you mention RGB to gray. Remember, this koala is still the BGR image. This koala original or orig is the RGB image. So here I am using koala, which is BGR. So I've said BGR to gray. If it is RGB, then you will say RGB to gray. That's it.
Let's say go Koila Gray in second line.
Okay. So here, as you can see, we have converted that image to grayscale. Now, whether you convert BGR to gray, RGB to gray, it is going to look the same. It's just you have to keep in mind what is the existing format. Based on that, you have to write this thing. In which line you are getting this error? And all of you write your doubts or any errors that you are getting in the everyone chat, okay, not the direct message, so that if I'm answering to something, others are also able to read what exactly I am answering, right? Or others will be confused. Yes, in which line you are getting this error?
I'm trying to upload to read the image, the panda image from my system. That's why I'm getting the error. When I try to see the image. Yeah, line 5.
Do you have the image in the same folder?
No. I have it in my system.
No,
It's
you
not
need
in
to
the
have it in you need to keep it in
Anaconda.
the same folder. Otherwise, you need to mention it
Yes,
in
I
the
did.
complete path. For
Yes, I
example, as you can see, I have this folder. So I have this notebook, OpenCV tutorial notebook, and all the images in the same folder. Then only it will work.
I mentioned the complete part.
You see, it will take time to figure out the path problem. Do one thing, check type of panda. What does it say? Type this and tell me what does it say.
Okay.
Quickly.
Okay.
You just need to type this, check the type of this object panda and tell me what does it say.
Non-type.
None type. So you are not able to read the image. You need to have the image. Whatever path you have mentioned, it is not working. And it will take me to time to resolve the path because I definitely don't know what is the directory structure of your PC. That is why, to be on the same page, to avoid wasting time, keep the images in the same folder. Create a folder, save those images, and then at the same location, you create this notebook. Got it?
Okay.
And also, if you are aware, I'm not sure how you have mentioned the path. You cannot just copy paste the Windows path and mention in the Python because The Python path, how it works is different, and what you see on Windows is different. Got it? That is why I suggested you just keep it in the same
This
folder.
is my code. I sent it in the chat.
Okay, as far as I recall, in Python, the way you mentioned path is a bit different. You see, it will take a lot of our time to figure out because I will also have to check.
It's okay. Let me stamp it
You
in the
keep it in
folder.
the same folder. That's why I said all of you keep it in the same folder.
Oh, thank you.
Okay, so we have seen how we can convert an image, whether RGB or BGR, to grayscale. Let us proceed to discuss the next function. So next function is canny. This function helps us extract the edges or patterns in an image. Let's see. So first we mention the image where we want to extract the patterns. And then there are these two parameters which are constants for the algorithm. We don't need to go into the details. You just have to mention them always as it is. And this function will simply return an image where it has extracted the main patterns from the given image. So let's see how the output looks like. Here. So I hope all of you can see this was our panda image, and it has simply extracted all the patterns, the edges from that image. Is it visible to all of you?
Sorry, what's this 150, 200?
This I said, these are two constant values that we provide for the algorithm that performs this process. They
Okay,
always have to be same.
always like any image.
Yes, anything, they will always be same.
Okay.
Okay. Now, sometimes we also need to highlight the patterns we have extracted. Now, application I can think of is, let's say you are dealing with a lot of high resolution MRI scans, or let's say X-ray images. You have to extract patterns from there, let's say tumors or TV spots or something. So let's say you have extracted, but now you may also need to, you have highlighted them. Now you may also need to, sorry, you have extracted them. Now you may also need to highlight them so that they are clearly visible. So now the next function is highlighting the edges. So for that, it will obviously take the output of this scanny function because that's where the patterns are. So for that, we have a function called dilate. This kernel is the same thing you have learned in your convolutional neural network. Kernel and filter are the same thing, just two synonyms.
I need.
And then you mention for how many iterations you have to do it. So the number of iterations control simply like how much you want to highlight it. So let us start with 5 and see how the output looks like. Let's start with 3 actually, so that you can spot the difference.
Reality comes.
Okay. So I'm not sure. Sorry, I'm not sure if on your screen, like whatever Zoom is doing, compressing and everything, you can see the difference, but I can clearly spot the difference. There is very little difference, but this is highlighted and this is kind of a little bit dull. Is it visible to all of you?
Yeah.
Yeah,
Okay, great.
yes.
Let's see what happens if we use more iterations. Now again, I can clearly spot the difference. I hope you can too. Let me increase the number so that it is more clear. Let's do 10. So now I hope you will see there is a clear difference. Yes,
Yeah.
more highlights are there, but it's not like more highlights are always good. It kind of changes. You see here the textures are patterns are clearly visible. Here it is not. So it's not like we just choose a higher number always. It depends on a lot of things. So this is our dilate function. Okay. Next we have a function which is opposite of this dilate function. Okay, which is known as erode. It is it reverses the effects of the dilate function. Let me write as a comment.
So this is how the filters are designed in the backend for Instagram.
Sorry, repeat again.
I'm just asking, is it how the filters are designed in Instagram or any app? You have filters.
Yes, they have their roots to the subject of image processing.
So in the backend, the might be similar to this kind of code.
Yes. I mean, code, I'm not sure, but the algorithms are kind of similar. Okay, most
Okay.
of them are performing that convolution thing only to. There are different filters that you can design. In image processing, there are different filters. If you give them suitable values, then using those filters, you can do a lot of things. So nowadays, they are using AI, but initially, when the filters used to be simple, like just sharpen your image or convert your image to black and white, okay, or smooth the image, okay, increase the contrast of the image, there the filters were used similar. But nowadays I think AI related tools are being used to create those filters, okay, dog shape. So I don't think any filter can do that. So it is definitely something else.
Yes, sir.
Got
Got it.
it?
Yes, sir. Got it. Thanks.
But the name obviously follows from here. Like filters, what are filters? A filter is simply that changes the property of the image. This term has come from the image processing subject, right? So that is why
Yes.
those also were called or termed as filters. Instagram filters, Snapchat filters, all these.
Yes, sir. Got it.
So here you can see a difference between these two. Like this was the image I have taken after the erode function. You can see these are a little bit lighter than this one. Let's mention more to see a difference. Okay, now you see it has kind of completely uh, disappeared. Like just to see the difference, I have mentioned this. Here it is. So erode is the reverse of dilate, you can see. Okay. So these are some of the important functions. Now let us talk about resizing and cropping, like how you can resize an image, enhance the resolution of an image, okay, or how you can crop an image. Let's see. These are actually more frequently used operations than the functions we have seen, resizing and cropping. Let me read the image again, the original image. Let me also have it in the RGB format. Okay, so I have read this image again so that we know the reference, what exactly we are dealing with. Now, first operation is resize. Now, this function changes the resolution of your image. Okay, so whatever the resolution you mention, and remember the resolution is always mentioned, although it is an ND array, but this function requires the resolution. So you will mention it horizontal versus vertical. So let's say the current resolution, if you remember, was 1400 by 931. Let's say I want to change the resolution of this image to 2000 by, let's say, 1400, somewhat similar aspect ratio. Done. Let's see how the image looks like. I mean, here you will not see any difference, but the resolution will be changed. So here is our image. Now, if you check what exactly is Panda 2, so you will see the resolution has changed. Now it is 2000 by 1400. Initially, it was 1400 by 930. Not only increase, you can decrease also. Let's say I want to reduce the resolution to, and always try to do it by maintaining the aspect ratio. So this is how your image looks like originally. So I have tried to give this a little bit similar to the original aspect ratio. What happens when you don't take care of that? See, let's say I give 900 and 900. So see what happens. So it becomes 900 by 900 resolution, and it kind of seems stretched vertically. But if you maintain the aspect ratio where the horizontal is more, vertical is less, somewhat the same ratio. So I think 900 by 600 should be enough. So now the resolution has decreased, but the image kind of looks the same as the original one. I think a lot of, if you have ever used things, then a lot of times you do this operation and then you may have gone through some website on online which converts the resolution or reduces the size. Maybe you are uploading images somewhere, you are storing them, you are transferring them, or you are filling some forms of something. So there they have these constraints. Okay, the size should not be larger than this. Yes or no? So there maybe you can use this Python function instead of going to some online website and doing these things. So simple
But sir,
function.
this like 2000 and 1000, does it mean pixels or?
Yes, pixels. Initially, this image had 1400 by 931 pixels. Now it has 2000 by 1400 pixels.
Okay.
One question regarding this, it's applicable OpenCV resizing applicable only the image or is document as well?
Document, you mean?
Means Word document,
No, 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 no.
PPT stuff.
Only images.
Only images. Okay.
It works on images. Why would you resize a document? I mean, the document is not really an image. A doc file isn't an image. It has no resolution.
Sometimes
Getting
you
my
need to,
point?
yeah, sometimes you need to upload inside 2 MB size of document like PDF or Word
Yeah,
documents.
that
So that
obviously.
time we
So
need to convert
no,
the
no. The
size.
if you are talking about image of the document, yeah, I think what you're talking about. You have a document and you have captured its image. So that image obviously you can resize, not the doc file itself.
Okay.
Is this what you're saying?
Yes, yes.
Okay. Yeah. If you have image, doesn't matter what that image is of, whether it's a person, an animal, or a dog. If it is PNG, JPG, or JPEG file, any file format you can provide here, and it will work. But not the PPTX, docx, those things. They are not images. Any image, any format is fine.
Okay, thank you.
Okay. Now let's
So
talk about.
I noticed something in the output. The shape of the image for my own is not 1 4, is 1000 by 200.
The shape of your image is.
1000 by 200. The yours is 1 4 by 2000. 1000 by 2000. Yours is 1 4 by 2000.
Then you may have mentioned 1000 here. Check what you have mentioned here. If you are mentioning 2000 by 1400, it will show you that.
Okay,
If
yes,
you have
I
mentioned
did.
2000 by 1000,
I
then it
did.
will show you that.
Okay.
Got it?
Yes, thank you.
Okay. So next operation is cropping. So have all of you practiced multi-dimensional slicing in ND arrays? Very important concept. Yes or no?
Using the colon operator,
Yes.
right?
Yes. For example, let's say
Oh,
if I give all of you a two-dimensional ND array like this, and I tell you, okay, extract exactly this portion. So can all of you do that? Let's say this is column number 0. I hope you know indexing starts from 0. 1, 2, 3, 4, 5. It is like that. So this is 2, 3. And then this is row number 0, 1, 2, and then here you have 3. So I want row 0, 1, 2 and column 2 and 3. So how we can do that? This portion. Let me give this task to all of you. Let's say the name of this ND array is, let's say A. So A is the name of this ND array, and I want these two columns and these three rows, basically meaning this portion of the data. Write the slicing code for that quickly. I hope all of you have understood the task. So we have some data here, or data is there. There are 4 rows and there are 6 columns. So I want the data in this portion, in this window.
vertically, you want 0, 1, 2, 3, all three rows, right?
No, 0, 1, 2.
Sorry, okay, 0, 1, 2.
And here 2, 3. Correct. 0 to 3, and here we will mention 2 to 4 because upper limit is not included. So if you mention 0 to 3, it will be 0, 1, 2, and here it will be 2, 3. Okay. So that's what cropping is basically. Very simple. Your image is your ND array, right? So by cropping, you can crop any portion of the image. Let's see. Now the original image is, 930 by 1400. Remember, while cropping, you have to remember this one is 930, 0 to, sorry, 0 to 929, and here it is 0 to 1399, right? That's how 930 by 1400. So let's say I want to crop a certain portion. All I have to do is exactly same as what you have replied to me for the last question. Let's say I want to crop vertically from pixel 200 to 600, and horizontally I want to crop from 400 to 1000. So as all of you can see, I have cropped somewhat around uh, 200. I think it should be somewhere here. To 600 should be somewhere here, and then 400 should be somewhere here, and then 1000 maybe here, because it is 0 to 1400. So just an estimate. So what you have received is this portion. I mean, not exact drawing, but just a random example how the cropping looks like. When you do phase detection, then the phase detection classifiers, cascade classifier or models, they return you height and width of where the face is present. And then your task is to crop the image based on the given height and width so that you can extract the face. It's like that. That's why this operation is important. So clear to everyone how the cropping works? Okay, let me give all of you simple task for practice. Try to crop this image in such a way, I mean, figure it out by trial, that you only receive this portion. I mean, I should see the eyes and the mouth only. Try to do that. Task clear? Like mention these pixel values in such a manner that you only see this portion. Okay, for almost 2 minutes, I was speaking with the mic turned off. So this is the result. It was just for some practice. Now, next we are going to learn about a very important operation, meaning how we can draw a bounding box. So have all of you been introduced to the concept of object detection and localization? Confirm.
Theoretically, yes.
Okay, that means all of you understand what is object detection and localization. Let me give you a quick review. So let's say you have an image, and inside that image you have some object. Let's say there is a cat. Okay, so object kind of looks more like a spider. Anyways, this is the object, and object detection simply means that you have to return an image. So output of object detection is basically coordinates where that object is present in that image. And then you have to give a final image by drawing a bounding box around that image. So this is what we call as bounding box. Okay. It indicates where exactly the object that we are interested in, that we are trying to detect, is present in your image. So we will learn how exactly we draw a bounding box. So this is as simple as drawing a rectangle. Bounding box is what is basically rectangle. So we need to learn how using OpenCV we can draw a rectangle inside an image. Let's see. Okay. So in order to draw a rectangle, let me ask this you all of you first. So let's say this is a rectangle and I have to draw this rectangle inside an image. So what I need to draw this rectangle, like what should I specify to the function? I hope all of you know the length and breadth are opposite sides are equal basically. So what I need to specify in order to draw the rectangle? Do I specify these two lines? Do I specify all four coordinates or what? What is sufficient in the most minimal manner to draw a rectangle? Tell me.
The opposite two sides.
Left and right.
The
Coordinates.
coordinates of what?
Coordinates of vertex.
The x-axis
All
and
four. Coordinates of vertex, you mean all four vertex.
Yeah.
no.
Okay.
Not
Is there any better way? Yes, Ifi.
if you can get the difference between the smaller rectangle and the bigger one.
No, no. It's not about the smaller and bigger rectangle. This is the image. Okay. Inside this image, you have to draw this rectangle. So what we need to specify in order to draw this? Because the
Okay,
function
like
has a lot of parameters, it can be confusing. That's why I'm giving this task to all of you first, so that you understand why we are specifying exactly what we need to specify.
Coordinates of the object that we need to draw the rectangle about.
No, right now we are only talking about a rectangle. We need to draw a rectangle. So what you need to specify to draw that? We are not talking about the object.
the vertices, the minimum and the maximum for the x-axis and minimum and the maximum for the y-axis for the horizontal and vertical axis.
No. Someone mentioned all
Diagonals.
four vertices. So the answer is around that. But we don't have to mention all four.
So is it diagonals?
You can
Not
give the
diagonal,
first
the
element.
principal diagonal. Okay, the principal diagonal. We have two diagonals. One is this, one is this. So this one is known as principal diagonal. Or to simply understand, you just need to provide the coordinates of these opposite vertices, this one and this one, and these two are sufficient to draw the rectangle. This one will have x and y coordinate with reference to the image. This one will also have x and y coordinate, and that's it. So you mention these two and you can draw the rectangle. Why? Because we know opposite sides are equal. So a rectangle can be drawn just by mentioning these two opposite values. Is clear to everybody? Why we need only two and not all four?
Yes,
Yes.
clear.
So does it mean if it's square, we only need one coordinate?
No, there also you will need two. I mean, with one coordinate, there can be infinite number of squares. This one, okay, this one, sorry, this one, and then this one. With one coordinate, there can be infinite number of squares. There also you need at least two.
Okay.
One question, it's only a square or we can assume rectangle as well?
A rectangle is square also. I mean, it's something basic. All squares are rectangles also. So we are learning how to draw a rectangle. You can draw anything using that. It's a square. Doesn't matter. No problem. The both all the sides will be equal. When we are learning how to draw a box, a rectangle. So squares are also rectangles. So you can end up build drawing a square also. Is this what you are asking?
No, I'm just asking this. The square is only applicable for here, the drawing the box, or we can use rectangle. Like opposite sides are equal, but different shapes, different like suppose 2 by 4, 2 is a breadth and height is 5. So opposite sides are equal, rectangle size, not a square. Like the
Not
image
really.
size, what we have seen image size 400, 1400 by 340, 331 is a rectangle, right? Not a square.
Okay. So Repeat the question with respect to your image. This image is okay, 1400 by 931. Then what we want to do in this image?
So if you capture this one, so it will be should be if you capture all the part of this panda, you need to have not perfect square. No, we need to create some rectangle, right?
Yes. No, I think all of you are missing the point. We just need to know, given some coordinates, how we can draw a rectangle inside an image. We are not talking about capturing the whole image or putting a frame around the image. That is not our goal. It is a requirement for object detection. For example, this is a, let's say, an image, and there is this object in this image. So after the image detection, whatever model you are using, that model will give you the coordinates of where that face is present. Now our task will be, using those coordinates, we will need to draw a box around that. So this rectangle function that we have in the CV2 library, it can help us achieve that thing. Okay, it can help us create a rectangle which we can use as a bounding box. This is
Okay.
what we are trying to learn. That is the purpose.
Okay. Thank you.
Okay.
Thank you. Yeah, got it.
So let's see how we can draw a rectangle. So it's a simple function and it works on the original image. It's not like it returns something. No, it works on the original image itself. It permanently changes the images. So let's draw a rectangle. First, we provide the image in which we want to draw the rectangle. Then we provide the first coordinate, for example, this one. Okay, this coordinate we need to provide. And next we provide this one. So let me just give some random values. And here also you need to keep in mind, this is x-axis, that means horizontal. This is y, x, y. This is xy coordinate of first point, xy coordinate of second point. After that, you have to provide the color. But the color you have to provide in RGB manner. Okay, 3 values. So let's say most of the times the bounding boxes are red. So I will simply provide red. For red color, what you have to do, 25500, meaning 255 shade of red, 0 of blue, 0 of green. So it will be completely red. You can combine to form any color. This is the way we specify the color. Then in the end, we specify the thickness of the line. Okay, so you can try with different values what works for you. Let's start with 5. So pay attention here. I'm not saying, okay, panda equals to this thing. So this function will draw it in the image itself. It's not like you need to save it some variable for the changes to be reflected. No. So here I hope all of you can see we have this bounding box in our images. Instead of 5, if I write 10, then you will see the thickness of the line is more. Now, you might be wondering, sir, how all of these images of resolution and different resolutions kind of appear in the same one. So this one is actually the default figure for Matplotlib. You can change the figure size if you want to make this image appear in a bigger manner. So what you see here is not because of resolution. This is a default figure size or fig size for Matplotlib. If I change the figure, see, let's say I make it, then obviously it will be bigger. Okay. So this is how you can draw a rectangle. When you perform object detection or any other task, then you will be given some coordinates. Maybe sometimes you will be given height and width. So using those, you will need to find these two opposite coordinates of the box, and then you can draw a rectangle for the final output. So the purpose of why we are learning, like it is something very simple. Okay, sir, we are here to learn machine learning. Why are we learning to draw rectangles? We are learning this because it will be used. It serves a purpose. So what is that purpose? Is it clear to everybody?
Yes.
A question
Yes.
for the inputs when you are trying to draw the box.
Sorry.
The third line, this 255, you say you want to convert it to RGB, right?
No, no, we do not want to convert it to RGB. Let me repeat again. This rectangle function takes these things in order to draw a rectangle. It takes the image where it needs to draw the rectangle. Then it takes the coordinates with reference to that image where the rectangle needs to be drawn. And then it takes the color of what should be the color of the rectangle. Okay. So I hope you know that colors can be represented as form of RGB. I'm saying 255 of R, that means as red as it can be, then 00 meaning I want to draw a red rectangle. By combining these three values, you can provide any color here. That's what it
Mm,
means. For
okay.
example, if I give 20 and then let's say 30 and then 100, so then whatever color is formed by that combination of RGB, that color will be shown. You can see.
Okay.
If I
Okay.
increase this value, let's say, so whatever color forms by that combination, that color will be there. So normally
We can
bounding
use
boxes,
the text of it, like
no,
saying red. You can't say red or blue
no,
or
no. You have to specify the color in this manner.
okay.
Let me check. I have actually never done that. No.
Mhm.
So we have to provide the color in this manner. Okay. So now we know how to draw a rectangle. So we basically know all the functions that we will need to perform face detection. Okay. Here we complete our short and simple OpenCV tutorial. Any doubts in any of these functions?
How do we actually detect the face here? Okay, we have given
That
few
we will
this.
learn, that we have not yet discussed.
Yeah, yeah, right. Okay.
That we will learn.
Uh, sir, is it like that drawing rectangle part will be part of the face detection? Yeah.
Part
Be
of
useful
the,
there. Face detection, will it be useful there? So
yes,
first
it
we
will be
draw
a
a
part of
triangle.
that process. So what
Okay.
happens is we will use something called Har cascade classifier. It will
Okay.
detect the face and then it will return the coordinates of where the face is present. Then it will be our job to draw the rectangle in the image using those coordinates to present our final output with face detection.
So which means like the image is divided like kind of pixels form. So it will search based on what shape you draw.
How it is detected, behind that there are different approaches, different algorithms.
Okay.
You
Yes,
can
sir.
use
Okay.
OpenCV method. You can create your own neural network that does it. You can train it. Okay, create a data set of your images and then train a neural network to recognize your face, right? So there are different approaches, different algorithms for doing that. Today we will be
Yes, sir.
using something that we will not need to train.
Mhm. Yeah, got it, sir.
OpenCV. Okay. So I think before starting that, let us go back to our neural network and see if it has finished training. So yes, so on this data set, we are getting almost 90, 85, 84, which are very good results for this particular data set. Now I think most of you were confused about that testing. First of all, I hope all of you know how to draw the training and accuracy graphs, accuracy and loss graphs. Yes or no? That how you can extract from the history the training and validation data and how you can draw graphs related to training and validation. Are all of you aware of that?
No, I'm not aware of that.
Have all of you heard of this history parameter, what it is?
I, I just heard it from you.
Okay, then I think it will take some time to explain this, but this one is more important than your OpenCV, very basic. So whenever you are training this neural network, all this information that you see here, okay, what is this information? Loss means your training loss, okay, loss on the training set. Accuracy means training accuracy, accuracy on the training set. Val loss means validation loss, loss on validation set, val accuracy, this one on the validation set. So whenever we want to check the performance of our model, we can create graphs where we mention training loss versus validation loss and the training accuracy versus validation accuracy. So that gives us an idea, okay, how the training journey of our neural network looked like. Fine. So how do we create those graphs? In order to create those graphs, we will need this data for all the 80 epochs. Yes or no? Let's say if I want to visualize the training journey of my neural network for 80 iterations, I will need this data, right? So how do we get this data? So when our model is being trained, it itself returns this data, okay, in the form of a history object. So as the object is history, I have also called this variable history. Let me show you what it has. Pay attention because I am explaining the history object, but I will delete this. So what type of object is this history? It is an object of class. What happened? Okay, so there's a problem. While we were learning the OpenCV, the runtime got disconnected and now it is not recognizing any of the parameters. So, which means in order to show that, I will have to execute everything again. Okay, which is definitely not feasible. So let me just explain what we are talking about. So this history is a history object. Inside this history object, you have a dictionary by the same name. So you said history is equals to model dot run, okay, or model dot fit. So while training, that model will return all the data that you see here, all of this data. So in that history object, there will be another object known as history, and this object is basically a dictionary. So in that dictionary, you will have the data about all of this. So you will have a key called loss. Associated with that key, you will have an ND array having the data about the loss values for all the 80 epochs that you have mentioned. Okay. Then you will have a key called accuracy. Associated with that, you will have the data about the accuracy for all the 80 epochs. Then you have val loss having data for validation set for 80 epochs, how it is reduced, and then val accuracy, how accuracy was for each of these 80 epochs. So that is the data you have. So from this dictionary, you can extract that data and then you can create a visualization of uh, training loss versus validation loss. Okay, how the loss of both the sets changed for 80 epochs. It will show you a graph, line plot simple, and then you can also see a curve of training accuracy versus validation accuracy. So this is what your history parameters is. I could show you by printing, but somehow the runtime is disconnected. Let me copy paste the code anyway. So as this history is a dictionary, history.history, history is a history type of object. That object has a dictionary type of attribute also by the same name history. So when you say history.history accuracy, you are extracting all the information about the training accuracy for 80 epochs. Basically these values from 0.1666 to this. So it will give you that ND array. Val accuracy will give you this data, 80 values. So then you can create a visualization for both of them to see how the training and validation accuracy changed from epoch 0 to 80. Same you can do with loss. Then we can create a visualization. What was the duration for your deep learning course? Like how many hours it was?
We had at least 10 lectures on deep learning, at
10
least
lectures, how many hours each?
2 to 2.5
So 20
each.
to 25 hours.
Yeah,
I think all these details cannot be discussed in the duration. Anyway, so now these two pieces of code will create a visualization which will show you okay how the training loss was and how the training journey was. Now let me also share how you will do evaluation on the testing set. So first of all, our model has been trained, so we make predictions on the testing set. But even before that, we need to normalize the testing set. Done, because our neural network works on normalized values. Now, we make predictions using our model, just like you may have done in machine learning. And I hope you may have also seen that whenever you make predictions using neural networks, so neural networks actually give you a vector of probabilities. Yes or no? For example, if you have 10 classes, so it's not like your neural network is going to give you a final output, okay, that this image is of a cat or airplane or something like that. No, it will give you a vector of probabilities, and then you have to select the index related to highest probability. Are all of you aware of that? What I'm talking about?
yeah.
Quickly confirm.
Not aware of the probability, but aware that it doesn't give a single output. There are
Yes, so it gives
we have to
multiple
select,
outputs.
yeah,
So
top
what are
five
those
or
multiple
so.
outputs? What are those multiple outputs? Tell me. Like what the question I am asking is, you have 10 neurons in the final layer and you are using softmax function. So what will be the output? What will the output look like for a single input?
uh, related to that, means related to models, top five.
Your voice is not clear. Related images? No, not at all. Let me make the question very simple. You see, this is even understanding these basics is even more important than any project. So my question, very simple question to all of you is, here is my neural network. Okay. In the final layer, I have 10 neurons and I have softmax activation function. I hope all of you understand that, right? This is what I have in the final layer. So I am asking what will be the output of this final layer. Doesn't matter what is the input. what kind of output you will see from this final layer? That is my question. Very important, absolute basic concept that should be understood by all of you.
1 to 10.
1 to 10 what? Like how many values you will have as output and what those
10
values
into
will look
one
like.
array.
Okay,
Uh,
okay.
we'll have 10 outputs, each with the probability of the object being the class. So if
Correct.
I
So we will have 10 outputs, let's say 10 by 1, we can say it like that. And all of those 10 outputs will be between 0 to 1. Yes. Basically, all of them will be probabilities. There is one more very important property that all of you are missing. The sum of all of those values will be equal to 1. Yes or no?
Yes.
Very important property of the softmax. Then only our classification will work. What the softmax does is it will take that weighted sum vector of 10 values and it will convert that into 10 values from all of those values will be between 0 to 1, basically daily probabilities, and sum of all of those probabilities will also be equal to 1. So what those values indicate is that let's say the first value is the probability that the model thinks this is the image of a index label 0, whatever that is, cat, airplane, we don't care. Then second value will be the probability our model thinks that this is the image with a label 1. This is a probability that this image is a label 2, just like that. So let's say the seventh value is highest. So that will be your final answer. But the neural network will not tell you that. This is the final answer of the neural network. Now it is your task that you need to extract the label associated with the highest probability. How do we extract the label associated with highest probability? We use a simple argmax function. So can anyone tell me what this argmax function does? It's a simple numpy function.
I'm just hearing the function today for the first time.
Your voice is very low. Can you repeat?
I say I'm just hearing it, the functioning function for the
Okay.
first time.
No, you may have studied it in numpy. Yes, all of you,
It
what the
returns the
argmax
index
function
of the
does.
maximum value.
Correct. So argmax function returns the index of maximum value. So we will get the index of maximum value, simply meaning maximum probability. So that will be our final answer. Yes or no?
Yes.
Right? What we are trying to do is the neural network is giving me a vector of probabilities. My task is to give the user, I mean, if I give the user 10 probability values and they will be in exponential notation. Haven't all of you tried printing these values? Let's say you create a multi-class classification project and then out of curiosity, you actually print these values and see what is happening. No? Have you never seen the output yourself?
No.
All of you should do that. You see, you should do a lot of experiments. I mean, I have taught you this project, I have tried to teach you each and everything, but still a lot of things you have to try it. For example, I have trained the model and now what I will do, I have shown the graphs to you, I have explained the history. I mean, I could do more if this disconnection issue was not there, but you can do it later. Print history, okay, see what is exactly is this history, then print the type of history, try to see what type of object is that, okay, and then see what exactly is history dot history, check the type of that also, so you will get to know it is actually a dictionary. You should do all of these things. Right here I have created a visualization, this is simple. Now here, before doing this, try to make prediction on a single value. So say model dot predict maybe extrain or extract whatever, 1:1. Then you will see the output. Okay, I see the output. There are 10 probabilities. Okay, the seventh value is highest. Just an example. So let's see what is the seventh label. Print the label. There you will see, okay, the seventh label is, let's say, frog, the image, then print the image, and then you will compare, okay, it is actually a frog. So my prediction is correct. All of you should do these things. That is how you learn. Let me complete this at least so that all of you can execute this and try. So by argmax, we will get their predictions for the whole test set. Okay, you should try for single values also. And then we can compare that with actual values. Simple scikit-learn accuracy score function. First, I provide the actual labels, those are in whitest. Then I provide the predicted labels. So this will give us the performance of our model on the testing set. So this is like two-way evaluation, validation plus testing. That's what we have done here. So this notebook I will share with all of you. You execute this and try to print individual, like before the argmax, try to print some predictions. Okay, what the predictions look like. Try to check the type of the uh, history and also history. Check everything. That is how you learn. And if you are confused about something, I think you can ask whoever is your next trainer. Obviously, they will answer. Fine.
Your Google Notebook looks connected, right? The connection shows a right.
That I
Why?
have reconnected. I have reconnected.
Okay. Okay, so you have to train it all over again.
Yes, that's the issue. See, it's not recognizing anything. I've checked that. I tried printing extra and white and everything. It's not recognizing anything. If I train it again here and we wait, so it will be, let's say, 30 seconds multiplied by 80. It will be more than half an hour.
Yeah.
What if we reduce the epoch like to 5 so that
Okay,
we can
so
see?
I think that's a good idea. We can do that. Just to explain those things, but then it will not give you correct predictions. All the probabilities will be same, right? You will not
Because
understand. History, I can explain, I guess. It's a good idea. Let me just mention 10 epochs. And then I can explain what exactly the history is.
I share something on the chat.
Yes, what you mentioned is correct. You have understood it absolutely right. This fit method will return an history object which will contain all this information, and I am storing that object into this variable. As it is returning a history object, this variable also have named as history because it's a normal standard we follow. Let's say if you have a class named history, classes names are capital, so its object name must be with a small letter to know what type of object it is. That's why I'm calling it history. It also makes sense because this will store the history of the training.
So when I check the type history type, that is the output I got.
Yes. This fit
It's
function
a
will
class.
return an history object, an object of class history, capital HISTORY. Okay. And that is why I am calling. I need it is returning something, so I need to store it somewhere. That is why this variable also I have termed as history. Even 10 epochs will at least take 3-4 minutes, so all of you can keep asking doubts.
So I have one thing I was trying to experiment. So like after predict classification of the images, like the one you gave, this 10 transfer using transfer model from other people. So I wanted to do something like a drawing, ask one of my children to draw a cat. Then the model can predict whether what they did is a drawing, is a cat or a horse or whatever. How do I implement it? I've tried to do that, but it keep giving me error.
Yes, so the way you can do that is, first of all, you need to upload that image here. You need to click on this icon, you need to click on this, and then you can browse wherever that image is. Let's say this is the image, so you upload this image here.
So,
Okay,
so are you
so
saying they
once,
need drawing it like using the drawing it on phone, like what you do with Doodle image and all those app?
no, it doesn't matter what it is, whether it's a drawing or something, you capture the image. Let's say if it is a drawing, so you capture the image with your phone or anything. Okay, and then you like store it in your PC, and from there you can upload it here. Got it?
So it must be saved first. There's no way
Yes,
to
obviously,
on the same window.
obviously. And even after that, you need to use that resize function. Okay, that resize function is used here also. You need to resize whatever image you have captured to the format this neural network is accepting images. For example, this one is accepting 32 by 32 by 3 images. So you
Okay.
need to resize that image to 32 by 32. I mean, obviously it will be RGB, right? So you need to resize it. You need to mention resize 33 by 33, and that image you can give to your model. You can say model dot predict that image, and then it will give you the output. Got it?
Okay, I'll try it.
I had one problem statement. So let's say we have a live camera or let's say webcam, and we want to detect some person's eyes, they're open or not, or they're closed. So for that problem statement, I one way was hard cascade. One way which I came across was dlib to determine if the eye is closed or not. Like in OpenCV using CV2, is there a way to determine in camera feed, like in the running
High
camera feed?
Cascade is OpenCV way also. Without OpenCV, how you will capture the video or frames and then do it? I think there is
Yeah.
OpenCV is the only way.
Okay. Okay.
OpenCV is the
So
only way.
in that way, do you need to extract the frames possibly with frames? We have to extract the frames mandatorily, or in the running camera video frame also we can do it.
No, that is the only way. You need to do it running only. Video is basically a lot of images moving
Frame, yeah.
one after the other. We call them frames.
We need to
So
extract the
I think
frames.
there is an XML file for this I related to I.
Yeah,
If you check that har cascade GitHub repository, there is a file. I'm not remembering the names. I something it is there.
yeah,
So you create a cascade classifier from that, okay, and then you apply a loop which keeps on capturing the
yeah.
images, and then that classifier keeps on pointing out, like putting a text whether the eyes are open or not. So that loop is basically your video. It will be like a live video,
Okay,
and you are detecting in a live video whether the eyes are open or not.
okay, got it. Thanks.
Okay. So now it has completed training. Let me show you. I mean, it is not the best possible accuracy since we are only training for 10 epochs, but let me tell you what is this history. So first of all, let's check the type of this history. So this here is a object of this class, history class. Okay. Now this object has an attribute known as history, small history. Let me show you what is that. Objects have attributes. I hope all of you know it by the same name. So this attribute is actually a dictionary. Dict meaning a dictionary. Now let's see what do we have inside this dictionary. So inside this dictionary, we have four keys, okay? Loss, accuracy, validation, accuracy. The values associated with the loss are all the values for all the epochs for training loss, training accuracy, validation, accuracy. To show you, if I print one of them, for this you need to know how dictionaries work. So if I do history dot history and then I extract the value associated with the key accuracy, so this will give me a list. Okay, it's good that it's a list, not an ND array. So a list of all the accuracy values for 10 epochs. You can check. When we started, what did we have? We had 0.1727 and finally 0.3995. So this is what it has. If you check loss, it will give you these values. Validation loss, these values, validation accuracy, these values. So that's it. This history simply keeps track of all this data. That's it.
Can we print it in a table
Why would you like to print it in a table? It is
so that
clearly
we see
visible.
all of them at the same time?
You can see all of them here. Values convey nothing. Visualizations help us understand better. So see what I'm doing here. Here I'm extracting the accuracy. Here I'm extracting the validation accuracy. Here I'm extracting loss. Here I'm extracting validation loss. Done. And then what I'm doing is I'm creating a visualization.
Okay.
See, this is a visualization of training accuracy versus training loss. So, okay, for whatever 10 epochs I have trained my model, this in blue, this is what the training accuracy looked like, and this is what the validation accuracy looked like. So these should be as close as possible, and there should be minimal fluctuations. Some will be there, but that's okay. So you see, so they are close. That means it is okay. The training is fine. Let's say if they are very far, for example, training accuracy is somewhere here, validation accuracy is somewhere here. That means we are having overfitting. If both of them are low, then we say it is underfitting. Same we
Please,
can do with the
please,
loss also.
can you repeat your last statement in interpreting the graph? Say the
So
red graph.
let's say at the end, if these two lines are close, so we say the training is okay.
Okay.
If they have very huge difference between them, let's say training one is here somewhat around 90, and then the testing one is very low, let's say somewhat around 70, so then we will say overfitting issues there.
Okay.
If both of them are low, let's say even after 100 epochs you're only reaching up to like 60, 40, so you will say underfitting is there. Try a different neural network like that. Got it?
No, I've seen it. I'm
So what
confused.
is this history parameter? Is it clear to all of you now?
Yes, the parameter is
Yes.
clear.
Others?
Mhm.
Yes.
Okay. So later you can change the value and try it with 80. Okay, I have shown it for 10 so that I can see quickly. Now let's see how exactly the predictions look like. Okay, so let me make a prediction on a single value. Now you may try something like this: model X train 0, but then it will give you an error. Why? Because you need the input in this shape. So that is why we use slicing. Okay, slicing gives the input in. Even if you want to provide a single value, you will do slicing. I hope all of you know, if I write 0:1, it means 0 itself. But because of slicing, the shape is maintained as per the original set, the original structure, whatever you have, ND array or something, list ND array, anything. So if I mention this, I will get the predictions with respect to that. So what is it saying? It is saying, okay, the model thinks. Now it is always better if you can see these values in a single line. So for that we have something called np.print options. You don't have to focus on each and everything, just the output. That's weird. Just a second. Okay. Now you see it in a single line. Fine. So here, if you count, you see 10 values: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, total 10, and they are in exponential notation. What these values means? So our model thinks that 7.7 into 10 raised to power minus 1 simply means 0.77. Our model is saying that this image, the probability that this image has label 0 is 0.77. Probability that this has label 1 is 2.3 into 10 raised to power minus 18, that is negligible. Okay, negligible. 0.17 times 0, then 2, 3, negligible. This one negligible. This says it has 0 probability. This one negligible. 0, 0, 0. The model says that there is a 0.22 probability that this model is label 8, and this is with respect to 9. So the model in this case is confused between this one and this one. Since it is not complete, we have only trained it for 10 epochs. I mean, if it was 80, it would have been sure what exactly is the output. So now you can use argmax function to extract the final output out of this. Okay, you can give this prediction there. And the argmax function will return the final label, the label associated with highest probability. Okay, and then you can even go ahead and create a function where you compare your labels with this list. For example, if 0 is the label, then you can see what is the value present at 0 index, and then you can print, okay, this image is an airplane. You can create functions like that also. So this is how we make predictions using the argmax. This part also clear?
Yes.
Yes.
How to make predictions using argmax. Okay. So most of these things will be same. Let me already
Please,
change
can
it
you
for
run
all of
it?
you. Sorry,
Can you run the arguments line of code?
how I?
As I said, can you run it, run the code?
So it gives you the final output, only one, zero
Yeah.
label. I'm kind of short of time. I was given limited time, but I'm trying to do as much as I can. So let me quickly create this function. So this function will take the image. The image has to be 2D. You will need to take care of how you provide. Okay. So
Okay.
result is equals to this. Now I can save this. Here in the result you have, so it is the result will be like a array. Still it will be an array. So you, if you want to extract the single value, you will have to do this. Okay, let me show you separately. So now you see it gives you a single integer. So we have extracted that. What we can do now is we can use it to make the prediction. So we will say simply print the image is from the classes list. We simply provide that result label that we extracted. So it will print that what exactly it belong to. That's it. This is your predict function. It will take care of everything. Now let's call this function. Make predictions. And then here we provide one of the values. So instead of confusing the user with the labels or vectors, it will just give a final statement. Okay, the image is an airplane. Okay, the image is airplane. Now, then you can print, then you can check the actual label also manually to see if your neural network is working fine or not. So actual labels are in Y train. So let's print what is the first label in Y train. This is the output. One is here. So basically zero label is the answer. This is the true label, which is absolutely correct. Our model was also predicting zero. You are also predicting zero. So that is how you can, it's a, you are kind of lucky that all of this is turning out to be correct. Even with just 10 epochs, the example I selected, the first one, kind of turns out to be correct. So you can understand it exactly same.
Thank you.
Okay, what we had was a vector of 10 probabilities. I created a function which can take an image. It will turn that vector of probabilities into a single label, final label, which will be the label which has highest probability. Okay, then using that label, I pick up the actual object from this list and I show a simple result that, okay, the image is airplane, correct? And then I can compare that with the labels to see if my
Shouldn't it
labels
be
are
y
correct or not.
test? Y train of zero mutant, right?
No, why should be? If I'm using X train, then the labels corresponding to X train are Y train. The labels corresponding to X test are Y test.
But we predict. Okay, okay. We generally predict on X test, right?
No, no. We evaluate on test.
Okay,
Prediction, I want to
valid.
see whether my model is predicting the images correctly or not. Those things I can do anywhere. X train,
Yeah, right. Nice.
XVal, Y test, I can do that anywhere.
Right.
Now, I'm extending this to a few minutes. Now, someone asked that, okay, how do we make predictions based on the image we have uploaded here? So for that, you can For that also you can create a function. How? So let's say define read image, right? So this function is responsible for reading any image that you have uploaded here. So you copy the path. So let's say first you create a path variable where you specify the path. Done. And then inside this image, your task will be to convert this image you have uploaded into a format that our neural network can accept, so that you can provide that image here and simply get your prediction done, right? So what you can do here is simply image is equals to, first of all you need to read that image from here. So image is equals to cv2 dot im
Right.
read, and then mention the path. Then you have to convert the color. So image is equals to cv2 dot cvt color image. Okay, so what is this function now? This function will read an image from a given path, okay? And let's mention it somewhere else. It will read that image from that path. It will convert its color because by default it will be BGR. It will convert it to default color. Then it will reshape it to as per the size accepted by a neural network. Then it will return that image. And that image you can provide to this make prediction function, no matter what you have uploaded. Okay, let's try. But you will have to change the shape of that image, see, because still it will not be accepted. So this is the path read image path. So this function will return an image. Let us check what that image looks like, if it is according to the standards of our neural network or not.
Yeah.
So the resolution is okay, 0 to 32. It is almost that. That is correct. But the color is a problem. Let me check what's the problem. Okay, you see, simple silly mistake in the name itself.
Hmm.
I just by mistake here I have written IAMAG. So the image was still the color one. That was a problem. Now everything should be correct. So you see here you have the image 32 by 32. Now this is ready. This is still not ready. Before providing it to that, you will have to add one more dimension. For example, if you try to provide this image, first of all, let's print the shape of this. So you have received that same error that input vector is of 4 or something. Now, what we can do to change this, we need to make its format as same as what the input is expected by our neural network, right?
Yeah.
So we need to add one more dimension in the beginning. Okay, we need to add one more dimension in the beginning. So what I can do is image dot reshape, and I can do 1 comma 32 comma 32 comma 3. Now see, so it's saying it's an airplane. Obviously, this object is not one of the, I mean,
Yes.
human face is obviously not one of the images we have here. This is just an example. Later,
Okay.
you can try with whatever images we upload. Very quickly, what I have done is I have tried to create these functions. So later, all of you can experiment with uploading your own images. I mean, obviously, this object is not present in our data, so it will just say anything.
Okay.
Fine.
Thank you so
So is
much.
it clear to all of you what we just did very quickly?
Yes, thank you.